Okay, last half of lesson 72. It's just really one more idea, but I wanted to go real slow on this. All right. What if we're asked to find the derivative of the absolute value of x squared minus 4? Well, x squared minus 4 is a simple parabola, right? Just like like this. X squared minus 4 is just a simple parabola. Pretty straightforward. Well, when I take the absolute value, everything here that's negative, right, the absolute value of the whole thing, that's the y value, the absolute, everything that's negative becomes positive, and it looks like this. Now I break this up into several pieces. Your book uses the absolute values, and I'm trying to make it a little clearer here. So I'm going to break it up into a bunch of pieces. All right, first I'm going to break it up when x is less than negative 2. When it's less than negative 2, that's here and here, right? That's just my original function. So f of x is just x squared minus 4. Whoops, x squared minus 4. And when x is greater than 2, again, is just my original function, x squared minus 4. Now what your book says is when the absolute value of x is greater than 2, it's the original function, x squared minus 4. All right. What about here at my corners? When x equals negative 2 and x equals 2, my function has a value of 0. But what about this section down here, right? Between negative 2 and 2, it's no longer x squared minus 4. It's the opposite of that. It's negative x squared plus 4. So it's negative x squared plus 4. Well, what is the derivative? So when x is less than 2, the derivative, let's go with green, I guess. When x is less than 2, the derivative is 2x, right? The derivative is 2x. When x is greater than 2, the derivative, again, it's 2x. Now again, your textbook says, you know, absolute value of x greater than 2, the derivative is 2x. What about these corners? At these corners, the derivative does not exist. The derivative does not exist. And what about negative x squared plus 4? Well, the derivative of that is negative 2x. Now, what would this look like if I were to graph it? If you remember in class, I showed you a graph of f prime. That's exactly what this would be. When x is greater than 2, actually I think I've got it on the next slide here. Maybe not. There we go. When x is greater than 2, it's a line with a slope of 2, right? So there's my line with a slope of 2. When x is less than negative 2, it's a line with a slope of 2 and an intercept of 0. So this is the line y equals 2x, right? And when I'm less than negative 2 and when I'm greater than 2, it's that line. Well, between negative 2 and 2, it's the line y equals negative 2x. So this has a slope of negative 2 and intercepts at 0. So between negative 2 and 2, this is the slope. But what happens at these corners? At those corners, it doesn't exist. So let's go back and look at this one more time. Turn that one off. There we go. When x is greater than 2, f prime is the line 2x. So when x is 3, the slope is 6. When x is 4, the slope is 8. When x is 2 or negative 2, the slope does not exist. But when x is between those two, when x is between negative 2 and 2, the slope is negative 2x. So at 0, the slope is 0. Right? See up here, look at my thing. At 0, the slope is 0. Well, why not? At 0, the slope is 0. At 1, when x equals 1, that falls into this region here, right? X equals 1 falls in this one, so the slope at 1 is negative 2. That looks right. Slope is negative 2. But when x is 3, that's not in this region anymore. I have to come down to when x is 3. What's the slope? When x is 3, that's this. That's greater than 2, so it's 6. When I'm over here at 3, the slope is 6. Right? So this has a very steep positive slope. that gets the only way to get used to doing this, the only way to be able to go backwards is to see this and graph this often enough going forwards. Once you've graphed this a few times going forwards, then when you see this is f prime, you start to recognize, oh, those are some corners. I've got a corner at -2 and at 2, something weird's happening there. Okay? Good luck.